Hello everybody. Thank you for selecting this video. I hope you will enjoy the subject that I have presented to you today. The idea of this presentation and this demo is to make data type vector, that is new in Iris since a few months, more visible and touchable. Vectors are often or mostly used for text analysis and can have some 100 dimensions, which is quite hard to follow and to interpret. So I decided to make a very simple example using geographic coordinates that have just 2 dimensions, and working with them is of course much easier, and also easier to understand what their results are meaning. One of the important features that were required is vector transformation. What they refer to is that geographic coordinations are based on a point 0, 0. This is this tiny point in the Atlantic Ocean, somewhere in the Gulf of Guinea, and in the middle of the water. Vectors from there to any place are interesting, are basically necessary for calculation, but it doesn't help for our example. What we require much more are vectors that point from one known location to other known locations. So I used a list of capitals with their geographic coordinations, and in order to use them as vectors, in our case, it was necessary to have a transformation that transforms the base from 0, 0 to whatever location we decide. And the data source that I found in the internet there is a list of 200 capitals with the countries, with latitude longitude coordinates in the typical format used in this environment. Well, copy paste of this table into a text file presented a tab separated structure that could be easy loaded. The challenge is that we have to transform for every item this coordinates into something usable for our vectors. And the decision I took was to transform this to integers first, and then applying north, south, east, west with a plus and a minus sign, so it was mathematically easy. The reason to do it with integers is an experience I had with Oracle Spatial, where I could win a benchmark just by transforming Geo coordinates into integers, since integer calculation was always faster than any other type of numeric calculus. So remembering this, I used this, and you will see the structure that we use in the next step. This is the table that I've prepared in Iris. You see the first 4 columns, as we have seen in the grid in the input. They all come in as strings. Then we have 2 vectors and we have a result. This is the base table that I use for working. To see the fields. ID is integer, you know. This is library string, which is varchar, vector, first vector, second vector, and then our vector cousin that presents the result, the similarity of the vector that we have calculated. So this is the base data structure, and now let's see how this works in practice. For the presentation now I use the public demo server that is also available for you for testing. Starting the demo program. Oops. Demo. Oops. That's okay. You see the well-done menu that I mostly use for my presentations. The first step is to initialize the tables. So I have a clean start point, import the data, it's next, and what you see already here, the initial loading of the vector has happened already. We run a simple select star from our table to see what the content is, what the actual status of the content is. Okay. So, and you see we have the content. There is a special line in the beginning for the 00 point that is used in relation with vector transformation. You have the integer version of the coordinates, plus for north and west, like here, minus for east, minus for south. So we have a clear coordinate system, and there is a base coordinates that always use the starting transformations, and the work coordinates where you calculate our vector, our distance vectors, our vector cosines. This last column is the cosine column calculated after a target has been, a start point has been selected. So interesting to see, we use here display mode. If I change to logic mode and execute it, you see that the vector rather unreadable in the internal format, which we do not need. Or you have the ODBC mode. That's again clear structure as we would expect it for vector coordinates. We are back to our web terminal and we have done import. Now we set the base location and take function 3. What is the city name? You just have to have the first view. I'll start with Madrid. Lucky punch. This is our start point. And now we generate our vectors again. And select a target location. I want to go from Madrid to, let's say, Helsinki. Hey, it's just one. And now, as the next step, now we have our base vector is from Madrid to Helsinki. And now we can see what other locations are in the same direction or close to it. And this is running now using vector cousin. I can set the similarity. This is default, and you see, of course, the vector to Helsinki with itself got a value 1. It's the best hit. But then you see close to it there is Tallinn in Estonia, Berlin in Germany, Riga, Latvia, Bern in Switzerland. Well, yeah. It's not so close, but you see, it's the worst match. The others are really better match. So, what does this filter mean? If I take another example, I set a start. Let's set a new start location from Madrid. Start a new target location going from Madrid to Beijing. Beirut, you know, we want to go to Beijing. And if we now go for the best matches, you see there is a quite interesting long list on the way. Ankara, yes, Seoul, yeah, and that's the experience that you have with your vectors. The angle between those vectors is always below your sensibility. Yes, but the longer the vector is, the broader the area covered becomes. And that's the great learning about this. Just a quick check of the content of our table after setting a new base. The first that you recognize that this is a new base, that 00, our original base point, has now a working base from something minus. So this means Madrid, our starting location, should have now as base for the vectors, the 0, 0. And here you see already the vector cosine calculated for these locations. It happens hand in hand with setting a setting a base location. And let's see where Madrid is. I remember it was something like Spain. This should be in Spain. Madrid. Where is Madrid? Here on the top we have Madrid, and Madrid shows 0, 0. That's the new base. From there, all the other vectors that you found before, after, are transformed to have a new center. And from there we calculate our vectors. What you also see in ODBC mode here is the value of our cosine, and that's double precision calculation as a standard. And you have seen it's running really fast. I admit we have just 200 rows, so whatever you do, it is fast. To check for the opposite direction, we have to set the similarity to -1, which means from understanding cosines, that's just backward at the opposite direction. And well, you see, the most opposition of Peking is Washington. Well, this is not a political statement there, but quite surprising. Ottawa, Saint-Pierre, yeah, and it gets a little bit closer, but it's definitely not the direction we want to go. So it was a little bit an exercise. Typically you narrow it down and say, okay, I want just the 999 and get still 11 locations on my way from Madrid to Beijing. Well, and now I would invite you to try it yourself on the demo server, or download the package and run it in Docker. Any feedback is very welcome. Thank you. Okay, this was the video. I hope you enjoyed it. I hope it was interesting to you, and I hope you will see me again with my next video on this channel. Goodbye.